Alright, dear children, now we are moving to next important term related to this mass energy equivalence, and this is actually a term which we define under nuclear level. Okay, and this is a term related to the nucleus of an atom. Okay, as far as the nucleus of an atom is stable and unstable, and one of the first term that we define is called mass defect. Now, mass defect is also called the loss in mass. Okay, so we also use the word loss in mass or change in mass. Okay, now this term basically defined because it has been found that the rest mass of the nucleus of a stable atom is always less than the sum of the masses of the constituent nucleons. Now, as you know, the word nucleon means what? Children, you know nucleons means protons plus what? Neutrons. So protons and neutrons present inside the nucleus are simply called as neutrons. And these protons and neutrons are different in numbers which are present in different nucleus of an atom. Okay. Now, what is the main part? Or it is been observed that every proton and neutron has a mass. So if there are 10 protons, then they are the mass of 10 protons. If there are 10 neutrons, means they are the mass of 10 neutrons. Okay. So if you measure the mass of all the protons and neutrons present inside the nucleus, this mass, and if you measure the mass, the rest mass of the nucleus of a stable atom, rest mass of the nucleus of what atom? Stable atom. Then that rest mass of the nucleus of a stable atom will always found to be less by a very small amount than the sum of the masses of the protons and neutrons, which are called nucleons, in the what state? Free state or in the normal state. That means this difference in the mass, if there is a difference in the mass between this mass of the nucleus and the mass of the nucleons present inside the nucleus, then this difference in the sum of the masses of the nucleons constituting a nucleus and the mass of the nucleus itself in the free state or normal state is simply defined as mass defect. We define as what defect? Mass defect. And this is not true only for one of the nucleus of an atom. Now this is observed for all the atoms of an element. Okay, so there are so many elements which has been discovered, but it is observed that there is always a difference in the mass between the sum of the masses of the proton and neutrons constituting the nucleus and the mass of the nucleus itself in the which state? Normal state or free state. And that difference in the mass is actually called as what defect? Mass defect. That's why let me just add a point out here that the rest mass of the nucleus, of an atom, and this atom we usually call as stable atom. And you know, stable atom means the atom which are not receiving any energy from outside, means the atom on the normal state. Okay, so as per the Bohr's theory or Rutherford observation is done, you know that atoms are Bohr's, especially Bohr's theory of atoms. Now atoms are usually stable when that atom is not receiving any energy from outside. And for a stable atom, the rest mass of the nucleus, that is for a stable atom, is always what? Always less than the sum. Let me use the word, the sum of the masses. Okay, sum of the what? Masses of nucleons. The nucleus which are present inside the inside the nucleus. And nucleus, as you know, they are nothing but protons and what? Proton and neutrons. Whatever number of protons and neutrons are there, they are simply called neutrons. In which state? Normal, or also called as free state. Because atom will be in two states. One is called free state or normal state, where the atoms will usually remain in stable state, stable atom. But atom will be in what state also? Excited state. When the atom in the excited state means the atom which receive energy from outside. But this is the case when the atom is in what state? Normal or free state. So when the mass of the nucleus and the mass of the nucleons present inside the nucleus are not exactly equal, That means there will be a difference in the mass. And that difference in the mass is only called as what defect? Mass defect. That's why mass defect sometimes we also call the loss in mass or difference in the mass. So from here I can write that the difference in the mass, the difference between, let me write down, difference between the sum of the what? Sum of the masses of the nucleon. Sum of the masses of the nucleons. This is for the nucleons. Okay. And the rest mass. And the rest mass of the what? Nucleus. Rest mass of the nucleus in free state. Free or normal state. Normal what? State is actually defined and measured as what? Mass defect. It's called what defect? Mass defect. So we define mass defect this way. And you know, mass defect is basically expressed by symbol delta M. Delta M is actually the symbol we use outer as mass defect. So as for the statement which I made, outer children, we can write mass defect by delta M, and this delta M equals nothing but mass of what? Protons plus mass of what? Neutrons, and these are nothing but the sum of the masses of nucleons minus the mass of nucleus, minus the mass of the what? Nucleus. Mass of the what? Nucleus. And this difference in mass is only called as what? Mass defect. Now this mass defect can be measured for any atom of an element. We can measure for any atom of an what? Element. So let me consider just for example for atom of element, and let me just write that element say as X. X is any element, okay, with their atomic number Z and mass number what? A. You know, atom of any element can be written in terms of atomic number and mass number. And Z is the symbol of atomic number, and A is the symbol of what number? Mass number. So A is what number? As I said, mass number, and Z is a what number? Atomic number. And you know, atomic number is the number of protons present inside the nucleus. Okay, atomic number. And mass number means the total number of protons and neutrons present inside the nucleus. That means mass number is also the total number of nucleons present inside the nucleus. So from here, if Z is the number of protons, Z is also called the number of what? Protons. Then the number of neutrons. We can also calculate the number of what? Neutrons. And you know how to calculate the number of neutrons, children? It's always mass number minus atomic number. You have done it. A minus Z. So A minus Z, that is mass number minus atomic number, always measure the number of what? Neutrons, sorry. But children, every proton and neutron even has a mass. And let me consider that mass is say MP. So I am writing MP be the what? Be the mass of each proton. That means every proton has a mass, that is MP. And even I consider m small letter n, and this is also the what? It is the mass of each neutron. So there are number of protons and number of neutrons. Then mass of each proton is marked by letter MP, and mass of each neutron is marked by letter what? Mn. But children, you know that even we can measure the mass of the nucleus, and that mass of the nucleus I write down as Mn, capital letter N. So capital N, capital letter N be the rest mass of nucleus. This is the rest mass of the what? Nucleus. So with this we can write the what? Mass defect, as we have already defined mass defect. So let me write the definition of mass defect. So mass defect delta M equals to mass of protons plus mass of neutrons. But you know, each proton has a mass how much? MP. And in this particular element, if there are how many protons which are present? Z protons. Then the mass of Z proton will be equals to Z into MP. Say example, if there are 10 protons, then the mass of 10 proton means 10 into the mass of each proton. Okay, like this. Then plus, then we have what? Mass of neutrons. So what is the mass of number of neutrons? A minus Z. A minus Z. Okay, mass of neutrons. Okay, bracket mass of each neutron, that is Mn, minus the mass of the nucleus, and mass of nucleus I have already considered as M. So this way we can measure the mass defect. So look at the formula that we can use for numerical problem to solve mass defect and to calculate mass defect is ZMP plus A minus Z bracket Mn minus M. So this is the relation that measure the mass defect. And children, when you measure mass defect, we basically measure in unified atomic mass unit. Unified atomic what? Mass unit. And that unit is symbolized by what? U. And this is the smallest unit that we can measure the mass of any of the particle, like electron, proton, nucleus, okay, nucleon, okay, these are the one. But in this relation, if you see, this M is the mass of the nucleus. Now basically, the mass of the nucleus is usually not known. So sometimes what happens when we do the calculation, sometimes the mass of the nucleus may not be known. Okay. So what is known by the experimental measurement is the mass of the atom. Yes, sometimes it will be given what mass? Atomic mass. Sometimes because every atom has a mass. No. So in that case what happens, instead of knowing the mass of the nucleus, sometimes by experimental measurement the mass of the atom will be known of that particular element. So under this case also we can measure the mass defect. Okay, and in order to measure the mass defect in terms of atomic mass, we can just use this formula only, but I write this mass of nucleus in terms of the mass, atomic mass or mass of the atom. Now in order to write the same mass defect as I said in terms of atomic mass, okay, now we can just follow the relation. Okay, now the relation will be like I write on, let, okay, M, let me write this way, M, X, the element we are taking X, Z, A. Okay, I am writing M, this M with X, Z, A, be the what? This is the atomic mass, be the mass of atom. Okay, let me write down, this is the what? Mass of atom, is the mass of atom of an what? Element. And which element we are taking the mass? That is X, Z, what? A. Okay, so if this is the mass of the atom of an element X, Z, A, okay, then this mass of atom means nothing but the mass of what? How many electrons revolve around the nucleus? Z number of electrons, because you know in an atom, in a normal state, you know what is the number of protons which is present inside the nucleus? Same number of electrons revolve around the what? Nucleus. Okay, and even there is what? There is a mass of the nucleus. So I mean to say, like in this particular element, how many number of protons are there? Z. So Z is the number of what? Protons. But remember that this number of proton is also equal to the what? Number of what? Electrons. The electron which revolve around. And you know we have already marked every mass of proton has MP, but even electron also has a mass, and that mass is also considered as Me. So Me is the mass of each electron. So each electron has a mass Me. So this atomic mass, now I write on this way also, X, Z, A. So this is the atomic mass of the mass of the element, and this mass is nothing but the mass of the nucleus, Mn, plus the mass of what? The mass of how many protons? How many protons? Z protons, Z electrons. And the mass of Z electron can be written this way also, that is Z into Me. So this is the number of electron into mass of electrons. But that's number of electrons, as I said, is equal to number of protons. So that's why atomic mass or the mass of the atom can also be written this way also. Mass of the nucleus, because atom consists of nucleus and the electron revolve around the nucleus. Okay, the mass of the nucleus plus the mass of Z electron revolve around the nucleus, and that is given by ZMe. Okay, so from this relation, what I do, I will make N as the subject, because as I said, in the relation, the mass of nucleus is not known. Okay, experimentally, the mass of nucleus sometimes may not be known. So in that case, this Mn can be measured as M, X, Z, A, atomic mass, and I'll take this to the left hand side, so it will be minus because I am keeping this Mn positive. It will be ZMe. So mass of nucleus can be expressed in this way: atomic mass minus ZMe. Now this relation now I substitute in the mass defect. You know what is the mass defect? Delta M equals to ZMP plus A minus ZMN minus, now mass of nucleus I replace by this. That means this quantity, so you can see this quantity Mn I replace by this. But there is a minus sign, I write down M X Z A. Now minus into minus will be plus. Now you have to multiply with the bracket, because in this case Mn means this quantity, so with minus sign, if you open the bracket, minus become minus, minus into plus is minus, and minus into minus is what? Plus. Okay, now let me just collect this term again. Okay, so in order to collect this particular term, let me just write down ZMP. Now I write these two together, plus ZME plus A minus ZMN, this quantity, minus MXZA. Now in the relation there is a common, in these two relations there is a common Z. So inside the bracket is MP plus ME. See, Z MP plus ME plus A minus Z Mn minus M X Z and what? A. Now see, mass of one proton and mass of one electron. Children, mass of one proton and mass of one electron means the mass of hydrogen atom. The mass of what? Hydrogen atom. So I replace this MP plus Me by the mass of hydrogen atom. Because one hydrogen atom, especially H1 hydrogen atom, consists of one proton and one electron. Okay, and one proton plus one electron is the mass of what? One hydrogen atom. That's why your mass defect now, delta M equals to Z. This is mass of one hydrogen atom plus A minus Z Mn minus M XZA. So look at the formula. There is another formula that we can measure mass defect. But children, this formula which we measure mass defect in terms of atomic mass. This also measures mass defect, but in terms of mass of the nucleus. Whereas this formula, that is delta M, also measures the mass defect, but in terms of what mass? Atomic mass. So this is the definition of atomic mass. Now corresponding to this atomic mass defect, we now define a binding energy, and that binding energy we will learn in the next YouTube video.